And now again, a small walkthrough of the solution to test 32.19 now. And again, it's very crucial to solving this task that you read through the information carefully, because you need to use all the information in order to actually follow and actually succeed in solving the task. Anyway, the idea is you have these again. The company Bela AS manufactures values salt and manufactures a cooling and heating system. Company's range include two steel valves, H10 and H25, both manufactured at the same production line. The production time at each facility is respectively 10 minutes for H10 and 30 minutes for H25. Total capacity of the plant is 100 hours per month. They spent 60 grams of steel for one of them and 30 grams of steel for production of the other one. The total amount of steel available for the production of the two valves is 12 kilos. There can be maximum sold 200 pieces of H10 and maximum 300 pieces of H25. Contribution margin per unit are respectively 32 for the one and 64 for the other. Okay, so we have these two products, and we know production time for H10 is 10 minutes, H25 30 minutes, maximum capacity 6,000, use of steel 16 for H10, 30 for H25. Match cell in units 200 of these, 200 of this. Contribution margin per unit is also known to us. So determine we're going to use Excel in order to solve it, because that's the method that I prefer that you use. But you of course also, if you're interested in using the graphical solution, it's of course also possible to use GeoGebra. Enter the maximum total contribution margin. That's the same as we had to do before. So again, we put this information in. We put the limitations here. We again match cell in units 1001, and then the optimum production mix will be shown to us after we use the solver. These figures, first off, we use the sum product function in Excel in order to find these first. Then afterwards, we'll find the contribution margin. The contribution margin will then be the focus of our solver function. The solver function will then give us the knowledge of, okay, how much should we actually produce? How much should we actually produce? We can see the optimal production mix in this case is 120 for this, 160 for this. So what we see is match cell in units reach 120 here, 160 here. So we don't really reach the maximum of any of them, but this is where we use our material the best and make the most money in terms of reaching the best possible contribution margin, taking our limitations into account.